Right, we've finally got here to the last question, question 7. Alright, now we've got the function fx equals k log brackets x plus a plus c. Now k, a and c are positive constants, so note that positive might be important. And we've got this information. The graph has a vertical asymptote at x equals -2, has a y-axis intercept at the value 2, and P is a point on the graph with coordinates B12. So we're going to need to use all of that information to find out these constants K, A, and C, and also B, I guess, further down. All right, state the value of A. Well, so we're looking at this bit here, x plus a. Now we know that the vertical asymptote will occur where x plus a is equal to 0, because we can't have the log of 0. And x has a value -2, so that means that we must have -2 plus a is equal to 0, so that gives us a is equal to 2. Find the value of c in terms of k. So we're not solving k yet, we want to find out what c is. Well, what other information do we have? We know that the y value is 2 when x is equal to 0. Okay. Well, let's rewrite the function with what we've got now. We know that the function is fx is k log x plus 2 plus c from part A. And we also know that 2, well, let's rewrite it like this. We know that f0 is equal to 2. So therefore we can set up this equation that 2 must be equal to k log 0 plus 2 plus c. What's happened here? Plus c. So that gives us 2 is equal to k log 2 plus c. So c must be equal to 2 minus k log 2. So now we have c in terms of k. Okay, find the value of k in terms of b. Alright, value of k in terms of b. Okay, well b, where does b appear in this whole thing? Well, it's up here. So we're going to have to use that information to get b into things. And we'll use our function over here again. We can rewrite the function as fx equals k log x plus 2 plus c, which is 2 minus k log 2. Okay, and we can substitute into that b, the coordinates of b12. So we know that when x is equal to b, fx is equal to 12. So we're going to have 12 equals, now what we can do to simplify this is take k out as a common factor first, and that'll be the log. Now x is equal to b plus 2 minus log 2 plus 2. And so we're going to simplify log b plus 2 minus log 2. This is going to be equal to b plus 2 over 2 plus 2. Now taking the 2 away, we get 10 is equal to k log b plus 2 over 2 And then finally, we can write k in terms of b. It's going to be 10 divided by the log of b plus 2 over 2. Okay, moving on then to part D, we've got a value for b. So then we want to find the values of k and c. All right, well, we're going to actually have to find k first, and then we can go up here and find out what c is. But we've got an expression for k in terms of b, so we substitute, we get k is equal to 10 over the log. Now b is equal to 2e minus 2, and then we've got plus 2 all divided by 2, and the minus 2 plus 2 cancel, so that'll be 10 over the log of 2e over 2, which cancels to 10 over log e, and the log of e is 1. So that's 10 over 1, so k is just equal to 10. Now we can find out what c is. 2 minus k, which is 10 log 2. So k is equal to 10, and c is equal to 2 minus 10 log 2. Okay, to finish off this question, we know what those constants are now, so we can write out the function with k and a and c in there, giving this expression here, fx equals 10 log x plus 2, in brackets, plus 2 minus 10 log 2. Now we want to find the exact, that's important, we can't use a calculator then, how many decimals, of the x-intercept. Now the x-intercept we know will occur when y is equal to 0, or when fx is equal to 0. So we need to solve when 10 log x plus 2 plus 2 minus 10 log 2 is equal to 0. Okay, now we can't just use a calculator, as I said, because I want this exact answer. And so that gives us the log of x plus 2 is equal to 10 log 2 minus 2 all divided by 10. And we can simplify that as log 2 minus 1 over 5, because 2 over 10 is 1 over 5. Alright, so using this, so you don't have to write this bit in, but this is what we're doing. So we get x plus 2 is equal to e to the log 2 minus 1 over 5. Now, this is e to the log 2 over e to the 1 over 5. That's just index laws. And e to the log 2 is 2. So we get x plus 2 is equal to 2 over e to the 1 over 5. And so x is equal to 2 over e to the 1 over 5 minus 2. Alright, now just check my solutions that I put up. And I did this a slightly different way. It just shows you if you don't break any rules, you'll get the right answer. Sometimes one way is more elegant than another. So I'm just going to do what I did in the solutions. What I did is simplified those two terms there. So that will give us 10 log x plus 2 over 2 plus 2 equals 0. And so you get the log of x plus 2 over 2 equals minus 2 over 10, which is that minus 1/5. So just writing that out. And then using basically what we've done here, that gives us x plus 2 over 2 equals e to the minus 1/5. And so x plus 2 equals 2 times e to the minus 1/5. Subtracting the 2, you get x equals 2e to the minus 1/5 minus 2. Same answer. That or that, same thing. And that's that test. Now that last question was, I believe, taken from a past exam. That's the sort of thing you're going to have to get up to. Practice makes those easier, where you don't panic with the fact there's pronumerals in there. You work your way through it. And if you want more practice with that type of question, the study guide is the place to go. It's not really that much like that in the textbook. So focus on study guide questions. Okay.